recording. So this session from this point on will be recorded so that later on I'll be able to save this, upload it to a YouTube account, and you guys will be able to access it to view it again. And for those of you that were unable to make the session live, you'll be able to time shift your viewing of it. Okay, so that works out pretty well. Okay, so I'm going to go through this PowerPoint, which kind of introduces us to elements of the course. I'm going to do something a little unusual. I'm not going to actually do it at full screen, because if I do that, I won't be able to see your comments or questions in the chat box. So I'm going to start out here. So first of all, my name is Tony DeVito. I've been an adjunct lecturer at Hunter for about 15 years. I've been doing biostatistics for every semester for at least the last 10 years or so. So trust me, if you're a little trepidatious about taking a math course, we've gotten a lot of people through this course, and we've got a lot of practice at it, so relax. So I think we're going to be able to accomplish quite a bit this semester. Okay, so I've also taught computers and public health research, a number of environmental occupational health science courses as well. I'm a local boy, Brooklyn Poly and Hunter, so I've been sitting pretty much where you guys have been sitting, where you guys are sitting right now in the past. So I will be teaching the live part of the lecture and all of the lab portion of this course. As I mentioned before, we usually teach this course as a team. So we have a lecturer and a lab person, and we're really both covering the same material on the same nights, but it's worked very well to get two different teaching perspectives or styles and get the material really presented to you more than once in different ways. And that's really worked out very well. Unfortunately, the other fella that I usually teach this with, this handsome guy over here, Dr. Levi Waldron, and also I teach it with Professor Weicker, who some of you may well know as well. But for instance, right now, Dr. Waldron is unavailable for the summer because he's kind of a specialist in big data, particularly in its application to genetic research. And he was the recipient of a Fulbright Award this year. So he spent the last semester teaching and doing research in Trento, Italy. If you see on the right side there, that's the Piazza Duomo in Trento. And I'm sure he's enjoyed many an espresso at one of those tables. And perhaps now that it's a little warmer, he's enjoying some gelato as well. So he will be present, but he'll be present as a recording. In fact, after this session is over, if you go through the Class 1 schedule from 1 through 6, you'll see that one of the elements, the second one probably, is that you go online and you listen to his lecture. And that was a live lecture from a previous semester that we think was pretty well recorded and pretty thorough. So we'll have various, I'm going to try and organize this so it's clear the sequence of material, particularly on nights when we're not getting together in the same room. So it's going to be a little bit harder for us to communicate. Okay, so that's Levi. This is my contact information. The best way to contact me is to use that email address, my Hunter email address. It would help if you put PH750, no spaces, into the subject line, because that will highlight it in my email, and I'll be sure not to miss it. You can pretty reliably depend on getting a response within 24 to 48 hours. Usually I try and answer them right away, but certainly within 24 hours to 48 hours. So you can contact me that way. Unfortunately, I don't have an office at Hunter as an adjunct, so getting me on the phone is going to be a little bit more difficult, and my office is usually parked down on 2nd Avenue at a meter. So that's the way it is with adjuncts, unfortunately. But I certainly make myself available. The other thing is that even though you're not required to attend the other sessions coming up, except for 4 of them, we'll talk about those 4, I will probably be broadcasting most of them from the lab in the basement at the Silverman building at 119th Street. That means that the typical situation will be that we'll play a lecture in that room, we'll play a recorded lecture, or if we don't have a good copy of a recorded lecture for that topic, I will give the lecture, but very frequently we'll be playing recorded lectures, and then I'll follow that up by doing for an hour or so, and then I'll follow that up for the next 2 hours by filling in information on that lecture and by presenting the lab live and broadcast. So that means that since I'm present there, if you have the opportunity to stop down there, you'll have the opportunity to get me to ask questions, to clarify issues, and so on and so forth. Okay, so our expectations. We don't expect you to have any prior knowledge of statistics. We hope that you'll make sure that you ask us questions. If you have problems, you'll keep us informed of any issues that you have. If you have to miss class, please email me so that I know that, particularly those classes that we have as required classes for you to be present. The first required class is going to be on Monday, so that we can get acquainted and go over this material, and so that I can answer any questions that you might have on it. Okay, so there's going to be two exams. They're open book, so they'll take. We don't want to. They're not memory tests. We don't want you to have to memorize a lot of material, but we want you to understand the material and be able to apply the material usefully in the future. There's going to be, instead of a final, we've been doing a project, a final project. It involves a presentation and a formal kind of poster based on that project. Don't get worried about that. We have plenty of time for that. We'll be discussing that later on in the semester as it comes up. And the presentation part is just 5 minutes. So, and we trust me, you'll enjoy doing the projects. You certainly enjoy more than having a final, I think. Okay, so again, keep in touch. Let us know if you have any issues or anything like that, so we know we know what we have to do to make sure you keep up with the course. Let me mention that's particularly important in the summer course. This course normally is 15 weeks long during the semester. Excuse me. During the summer, we really only have 7.5 weeks to complete this course. So if you start to fall behind a couple of classes, it's much more difficult to catch up. So it's really important that you keep up with the readings, keep up with the lectures and the labs, and and any homework assignments that are involved as well. Okay, so we'll be able to communicate by email. We have a Blackboard discussion group, which is going to be a way for us to communicate as well as have some peer-to-peer communication. And I'll have some online office hours that I will be scheduling as well, and you'll be able to get me if you come into the sessions that we have in person. Okay, learning objectives for tonight. Well, first of all, we want to make sure everybody has access to Blackboard, that you know how to connect and that this is working for you online, that you'll be able to get to the YouTube videos that we store, and so on and so forth. We want to make sure that you know how to get to the room that we'll be working in. It's going to be C09 in the Silverman building, and we will be broadcasting from there. So if you can't get into the sessions, you'll be able to watch them online. In fact, if you prefer to watch them online, you can do that as well. Just keep in mind those sessions we need you present for. Those are Monday, the 2 exams, and for the presentations on the projects. We want you to get familiar with the syllabus today, and then we're going to get into some actual starting statistics. We're going to start to talk about different data types. We're going to take a look at some of the software tools we're going to be using, and we're going to get an idea on using graphics for presenting statistical information. So it's pretty interesting stuff, and I think you'll enjoy it. Now, the software is going to be a little bit of an issue because we're going to be using two primary pieces of software this semester. Let me just go over the syllabus. Actually, let's take a look at the syllabus. I should be able to open a copy of that. Let's see. Okay, here's our syllabus. Okay, in the syllabus you have information about the textbook, the software we're going to be using. The textbook is going to be an open source textbook, which good news is that means free. You can download a PDF version of this at the links that we've given you on Blackboard and in the syllabus. You can work strictly with the PDF version of this. If you want a hard copy of it, there's at least 3 different methods of purchasing online printed versions of it for anywhere from about $10 to about $30. Okay, we're also going to be using some software. I'm going to wait a second to talk about the software. As far as the course grading policy is concerned, the homeworks account for 30% of your grade. Okay, so that's more than any individual exam does. Okay, between the homeworks and class participation, and the final project, which you have a lot of control over, what kind of grade you get on, they count for more than the two exams do. So it's important you keep up with that stuff, and it's an opportunity for you to improve your grade. My policy on the homework typically is if you submit it on time, then you get a second chance to resubmit it for higher grade. So it certainly makes sense just from the perspective of keeping up with the course, and also from turning that homework into a guaranteed 30% of your grade is going to be pretty good. So it really pays to keep up with that material. Okay, attendance and class participation, either online or in person, except for those 4 sessions. And if you have a real problem that keeps you out of one of those 4 sessions, including the exams, let me know as soon as possible. Okay, so, and I think we have an image that shows the dates that we're required to be in class. We have the readings and the materials and the schedule for the homework as well. And I also included in the syllabus the academic calendar, so you know what the deadlines are and when the grading situations for the different grading situations and tuition situations as well. Okay, but my objective here is to get everybody through this course. So hopefully that won't be of any relevance to any of us. Okay, so for starters, any questions on the syllabus or the material in the syllabus or on the textbook? Okay, somebody type something in there so that, like, I know you're still there. Okay, good, thank you. Excellent, great. Okay, so let's talk about the dates that we're going to be attending here. Okay, so actually let's move on to, okay, we've got syllabus out of the way. Okay, and just let me see what I got here. Yeah, let's talk about software. Now, as far as software is concerned, okay, we're going to be using 2 basic kinds of software here. In statistics, we have to organize a lot of information. Okay, when I took this statistics course, believe it or not, in the late 60s, as an undergraduate, when I took a undergraduate statistics course, this is the equipment that I was using in that course. Little antiquated even for the time that I took it, but we've come a long way since then, as you can probably see. One of the most basic, widely used pieces of calculating software that's around right now is Excel. And Excel is a version of a spreadsheet. Let me just check my questions here. Yeah, the reason why there's a question about the presentation nights. The presentations will be on the 20th, which is oops. I guess there's a problem with one of the dates on there. I'm going to have to check the dates. There's the last date of the class is a Monday night, I believe, and but there is an additional Wednesday that is part of the semester. If it's necessary or desirable, and not everyone's able to present on that Monday night, we also have that Wednesday night that's available. But it's that last Monday night. Let me open that up just so I can make sure I know what's going on. Okay, so let's see what we got. So I got the 22nd for Monday. Let's see what the actual date is. So July. Oh, you're right. You're absolutely right. That should be the 25th and the 27th. So the last date of the class is the 25th. Okay, so you can assume, forget the 22nd there, you can assume that the presentations will be on the 25th on the last day of class. Okay, is that clear? I'll make that correction in the syllabus. Okay, good. All right, I got to remember to make that correction. So let me get back to software. So spreadsheets are enormously valuable tools to us because they're a form of software, a form of calculating device that you can use for all sorts of purposes. You can use it for financial calculations. You can use it uh, uh, for mathematics, for statistics, for basically anything you want. It is a generally used, valuable piece of calculating software. Now, many of you probably made extensive use of Excel or some other spreadsheet program. Some of you may not have used a spreadsheet program very much. So for the time being, don't worry about that. You'll have plenty of practice, plenty of chance to learn about it. And those of you who have used a spreadsheet program extensively in the past, hopefully you'll get some maybe additional tips or find some additional operations that you weren't using it for before. So you can read through this, but basically the main issue about using spreadsheets is they present data in a certain way. Okay, the cells that each one of these little blocks or cells, as they're called, can represent any one of three things. It can represent a number, for instance, $12 million, can represent a label such as car loan or number of payments or something like that, or it can actually contain a calculation based on other cells. Okay, and we're going to play around with that a little bit later on. But so spreadsheets are kind of one of the things that we're going to need to do some basic calculations in this course. So you should have a copy of Excel or some other spreadsheet similar to Excel that you have access to. Okay, now there are actually open source versions of the Microsoft Office products, such as Excel. There's a product called Open Office, another product called Neo Office, which are free to download if you're really stuck for cash and you don't want to spend the money on it. We can probably get through most of what you need. Now, all of this software, Excel and the other software that we're going to be talking about, is all accessible on computers in the labs at Silverman or throughout the CUNY system and in the library as well. So in the beginning, if you need to access it, you don't have it on your own computers, you can always use the computers at schools. Now, I strongly recommend you actually do manage to find copies or purchase copies for yourselves, especially the one we're going to talk about in a second. The other kind of programs they use to manage data are things like database programs. Microsoft has one called Access. There's one on the Mac called FileMaker Pro. For the most part in this course, we're not going to be playing around with them very much. Okay, but we will be playing around quite a bit with spreadsheets, like particularly Excel, and we're going to be using a particular form of software. It's called vertical software. In other words, software for a specific purpose called SPSS. Now, SPSS stands for Statistical Package for the Social Sciences. It's currently owned by IBM. They market it now and maintain it. This software is specifically designed for statistical calculations. Okay, and we're going to be using it for most of the operations that we do this semester. Okay, so it's important that you become familiar with this particular program. Now, there's a couple of ways you can manage to buy this program. The cheapest, easiest way is to download a copy from a distributor of educational software. I think it's onthehub.org, I believe. The link is on Blackboard and in the syllabus as well. You can download a copy of it. There is a version of it called Grad Pack. There's two versions of the Grad Pack. One is called the base version. One is called the I think one is called the standard version. There's a base version and a standard version. For our purposes, for this class, the base version is sufficient. If you think you're going to be taking some more advanced statistical courses, you might want to purchase instead the standard version of the grad pack. Not much difference in cost. The base version for a 6-month license costs about $45, and for a 12-month license costs roughly $75 or $80. The standard version, I think, costs about $55 and about $90 or so. So it's a little bit more expensive. But if you think you're going to need it in future semesters, you might want to consider upgrading to one of the next versions. Okay, so at a minimum, we'd like you to purchase and download and install on your machines the base version. And for our course, obviously, 6-month license is going to be sufficient. Okay, so SPSS opens up and looks very much like a spreadsheet program, but functionally, it's really quite different. So we're going to be taking a look at those differences as we go forward in the semester. Okay, so let me get this out of the way. Get an idea of the two main pieces of software that we're going to be working with. Okay, so let's talk about what material that's going to be covered in the lecture today. Okay, so I'm going to open this up. We're going to talk about data types. Okay, now what's important the reason why data types are important to us is because the type of statistical analyses that we're going to do are really going to be different depending on the form of the data that we're working with. So the main kinds of data that we're handling are going to be one of these 4 different types. Really kind of 3, but let's break it up into 4 different types. The first one is nominal or categorical. That's data that is basically just either a name or a category. For instance, gender, male or female, is nominal or categorical data. Hair color is categorical or nominal data. You'll see us pretty much use these words interchangeably. Now, other forms of data are numerical data. For instance, a blood pressure, a blood sugar level. Okay, they are numbers that are part of a continuous scale that can have a certain range. So blood pressure might be continuous data. Blood sugar levels might be continuous data. Your weight is a continuous data. Height is continuous data, and so on and so forth. You'll see it in the various pieces of software we're going to be working with. Sometimes they'll refer to it as numerical data, or scalar data, or continuous data. So that's a certain kind of data that we're going to be working with differently than we would handle nominal data or categorical data. Okay, occasionally you'll hear us refer to numerical data as discrete data. Discrete data is numerical data that is typically an integer type measurement. For instance, number of siblings is a small number and happens to be, it's always going to be an integer. So number of siblings might be a type of numerical data, but discrete numerical data because it's an integer. The last type of data that we're going to be coming across as well is ordinal data. Now, ordinal data is something that rests on that represents a scale from high to low, but it's different than continuous data because the differences between each level are not necessarily the same. For instance, we know that if we're looking at numerical data such as weight, the difference between 110 pounds and 120 pounds is 10 pounds. That's the same as the difference between 170 and 180 pounds. With ordinal data, we're looking at a different kind of order, but in a sequence from low to high or high to low. For instance, a rating for a movie might be excellent, good, fair, or poor. So that's a distinct range of ratings, but we don't know really whether the difference between excellent and good is equivalent to the difference between fair and good. Okay, or as for a pain scale, if I asked you what level of pain are you experiencing right now, being in the statistics course, and you told me the level of pain was 8, we wouldn't know if 8 was whether the difference between 8 and 9 was the same thing as the difference between 3 and 2. Okay, so we can't quantify exactly what that difference is, but they do have an order. 8 is greater than 7, is greater than 6, is greater than 5, but we don't know relatively whether one person's 5 is the same as another, and whether the difference between a 5 and a 4 is really equivalent to the difference between a 9 and 8. So that's ordinal data. So that's going to be analyzed in a different way than maybe its other data is analyzed. Okay, so let's take a look. Occupation. Anybody want to hazard a guess? What is occupation? What kind of data is occupation? Don't answer too quick. See, now I'm hoping that you're not answering because there's a lag in the internet. Nominal. Okay, good. And all right, good. Rather than you falling asleep already. My voice is a little hoarse because I'm just getting over a cold. So hopefully next time you hear me, I'll be easier to listen to. How about social status? Anyone want to get upper, lower, or middle class? What kind of data is that? Okay, it's categorical, but it's got order. So it's ordinal, right? But it also, you could argue it's categorical as well. How about mortality rate? 300.2 deaths per 100,000. Numerical, good, okay, good. Self-risk, obviously ordinal. How about your number of siblings? Okay, discrete, right? It's numerical, but it's discrete numerical because it's going to be always going to be a number. Blood level in micrograms per deciliter. For instance, and currently I think the action level for lead level for children is 5 micrograms per deciliter. That's numerical, exactly right. Okay, good. So we got a good idea what that is. Okay, so now how do we deal with this stuff? Well, when we deal with nominal data, well, we really can't do averages. We can't do too much manipulation with the numbers that are involved in nominal data. Basically, all we can do with nominal data is count the frequency, compare the frequency. So basically, we have 9 people here, right? And as it turns out, 4 of them are male, 5 of them are female. So with nominal data, we're most likely going to be examining it first as frequency, okay? And with numerical data, we're going to be looking at it quite differently. With numerical data, we can have a lot of different measurements of how numerical data. Oops, I got messed up here. Like I said, I'm doing it this way because I want to be able to see comments or answers or questions and stuff like that as we work through this. Okay. Okay, I jumped ahead there. Okay, so one other thing I want to mention to you is, I think I'm missing something here. Okay. Okay. One of the things that a lot of the stuff that we're going to be working with is going to be the idea of taking a sample from a population in order to estimate what the nature of that population is. So, for instance, we don't get the opportunity very often to measure an entire population. Usually, we have to take a sample from that population in order to understand what that population, what the nature of that population is like. Can anybody tell me the one place that we wind up with information about an entire population? Anybody have an idea where that might occur? Yeah, there you go. The census. Every 10 years, we do an actual count of the population, the family size, income, so on and so forth. And find also prison, I guess, also. Yeah, I hadn't thought about that one. But I guess you're right. In prison, you know everything there is about that population for sure. Okay, so when we're dealing with information about a population, we refer to that as a parameter. For instance, if we're talking about the average age for a population, that's a parameter. If we're taking a sample from that population and we're averaging that sample, we hope that that average gives us an idea what the population average is, but in that case, that average is a statistic rather than a parameter. If it involves the population, it's a parameter. If it involves a statistic, if it involves a sample, it's a statistic. Okay, number of workers injured in falls in 2012. Okay, what is that? That is a, if it's the total number of workers injured in falls, OSHA keeps data on it. That's a parameter, right? A median age of 32 randomly selected firemen. Statistic? Bingo. Mean number of children per household in the United States. That's a parameter, right, for U.S. statistic. Mean number of nuisance dust levels for 10 randomly selected workers. Statistic, good. Okay, no problem there. We understand that. Okay, good. So let's talk about descriptive statistics. The statistics that we're going to take from a sample to describe a population. Okay, so first one, that's how we wound up jumping a little bit ahead because of what I'm trying to do with this presentation. Okay, so at any rate, when we work with nominal data, we're most interested in a frequency. We're certainly not interested in average. The average, if I have 9 people and if 4 males and 5 females, the average gender really doesn't mean anything, right? I can't have, in this case, 4.5 male females or something like that. Okay, so that really has no meaning. When we're dealing with numerical data, we have a lot of flexibility in terms of how we can describe that data. For instance, we can describe the range of that data, the lowest number to the biggest number. We can describe something called the interquartile range. I'm not going to get into that right at this moment. We can talk about something called variance, standard deviation, skewness, right skew, left skew, and so on and so forth. As we go forward in the next week or two, we're going to be defining a lot of these descriptions of data. Okay, so now very frequently we're interested in looking at how these description. I'm not going to show you that right now, but the numbers we just looked at here, range, variance, standard deviation, these are all numbers that describe numerical data from a sample or a population, but they describe how it's spread out, its range, how far apart the values are. On the other hand, we're also very interested in understanding where the middle of it is. And one way to describe the middle is just to take the numerical average, the mean. Don't worry about that formula for right now. We'll talk about that as we move forward. Okay, so another measure of central tendency, another measure of the middle of the sample or the population is besides the mean, is the median. So in this particular case, the total here is 550. There's 10 values here, so the mean is equal to 55. Another way to represent the middle is the median. The median is the middle number. So in this distribution, the median is 20. In this distribution, well, we don't really have a middle value here, right? So what do I do if I don't have a middle value? Those of you that have taken a little statistics before, what would be the median of this particular sample? What do you think? Since there's no middle value, what would you do here? Yeah, 35. You just take the two middle values and take the average of those two. So it's midway between 30 and 40, so it's going to be 35. So we have two ways of describing the middle. We have the mean and the median. We have many ways of describing the spread. Okay, there we go. Okay, so another measure of central tendency is the mode. The mode is the value that occurs most frequently. So in this particular case, what do you think the mode might be here? What value occurs most frequently? Yeah, 30. Yes, 30. When we show this in the form of a histogram later on, a form of a bar graph called a histogram or a distribution, it's this idea of a mode and the mean and the median are going to be a lot clearer. Okay, so let's go back over those measures of variability. We got the range, we have percentiles. Okay, so now percentiles represent where a particular value is in relation to all of the data lined up lowest to highest. Okay, so for instance, when you took the GREs, if you took the GREs recently, one of the things that happened was you got a score, and that score was presented as a numerical value, but it was also presented as a percentile. So if you were I guess 90th percentile, that would mean that 90% of the scores were below you and 10% of the scores were above you. So it's very common to present data, describe a population based on the percentiles. Let me go down. Oops. Okay, so here's a measure of variability described as a range percentile, described as percentiles and in this case, something called the interquartile range. Okay, so let's take a look at the percentiles. Okay, so the lower 5 values are the lower 50%. So the 50th percentile is the middle of this range in numbers. Okay, now down here is a point where the 25% of the values are below, we have the lowest 25% of the values, and up here is we have the highest 25% of the values. So in between those two, we have the 25th percentile to the 75th percentile. That range is called the interquartile range. So in this place, the interquartile range appears to be between 30 and 80, or approximately 30 and 80. Don't worry about the exact numbers for right now, because it's not really going to be the way that we calculate this anyway going forward. Okay, so we have this idea of range, we have the idea of describing data by its percentile, and we have this idea of interquartile range, the 25th percentile, the 50th, the 25th to the 75th percentile, and the 75th percentile on up. But that interquartile range is important to us because the way data usually distributes is most of the values are close to the mean. Most people are close to an average weight. Most people are close to an average height, right? So that idea of that middle 50 percentile is important to us, knowing where the mean is, knowing where the median is, and knowing where the most of the results wind up being. Okay, so some reason that keeps coming up. Okay, so there's a number of ways that we calculate this idea of spread, of variance. Okay, so don't worry about these formulas for right now. We're going to run through a quick example of calculating a variance and a standard deviation, and it's going to be a lot clearer to look back at these formulas and understand what they actually mean once we actually run through a manual calculation of these. Okay, so once we start to organize this data, one of the things that we can do to really understand and communicate this information is to display it graphically. Oh, yeah, every once in a while, if my voice drops out, it's most likely the internet connection. And if it's just you, it's probably your end. If everybody's complaining at the same time, it could be my end. I have a pretty good connection here. I'll tell you, as we get through this, I'll tell you where I'm doing this from. It's a little unusual. Okay, so there's a couple of kinds of ways of displaying nominal data that we've discussed already. Because it's frequency data, we usually display it as a bar chart. Okay, now we have a special form of bar chart that we use for numerical data that's called a histogram. If it's nominal data, such as gender, as we have here, it's called a bar chart. If it's numerical data, it's called a histogram, and the distinction is going to be pretty clear to you pretty quickly. Okay, so here's a bar chart. Here's another bar chart. Okay, that's a whiskey bar chart. Here's a candy bar chart, and there's a sushi bar chart, of course. Okay, so at any rate, the difference between a bar chart and a histogram is a bar chart is used to display nominal data or categorical data. Okay, each bar represents a different value: male, female, redhead, brunette, blonde, blondes, right-handers, left-handers. Okay, and usually there's a space between them because there's no relationship really to connect them. People are either in one or the other. Okay, a bar chart, a histogram is different than that. In a histogram, what we do is we wind up creating ranges for each one of these bars. For instance, all the values, I'm not going to try and read these, but all the values from 5 to 10 might be in this bar. From 10.1 to 20 might be in this bar. From 20.1 to 30 might be in this bar. And these might represent the frequency, the number of people, the number of subjects in that sample that represent that range of numbers. So in this case, you notice that these vertical bars are all connected. That's because each person is going to be either in this bar or this bar, and as their value goes up, they'll be moved from this bar to this bar. So these are really continuous values. There's not any gaps in here for people that don't aren't represented here at some point. So this is a histogram, very different from a bar chart for the kind of data that it describes. Okay, so here's a typical way that we might create a histogram. For instance, in this value here, these might represent weights. For instance, this is 100 to 109, 110 to 119, it looks like, and so on and so forth. And here are the values. These are the values for all the people in this study. They're grouped together in these ranges. There's 3 people in this range, 8 people in this range, 12 people in this range, and the heights of the bars represent the frequency. So for instance, between 110 and 119, we know that we have 8 people, and that's the height of the bar, represents the frequency or the number of subjects that are represented within that bar. Okay, so another way we like to describe display data to describe its range and where the middle of it is something called a box plot. And in this case, this box plot is representing a sample that has the lowest value is roughly around 5. The highest value is 52. So these 2 fine lines called feathers very frequently represent the lowest value and the highest value. Okay, this box in the middle represents the quartile. Okay, so the quartile, the middle quartiles. Okay, so or the interquartile range. So the 25th percentile represents about 21. The 75th percentile is represented by the value 42. So 50% of the people, the middle 50% of the values in this sample are between 21 and 42. Okay, and again, the highest value is 52. Okay, so this gives us an idea of the range of the middle 50% of the people in this study, or the subjects in this study. Okay, the black bar in the middle represents the median. Notice the median's not in the middle. That's a little unusual. We would usually expect the median to be in the middle here. That's going to be significant to us later on as we move on, that the median in this particular situation is not in the median, or the 50th percentile is not in the middle of this bar. Okay, so this represents the middle 50%. So why is this particularly an interesting way to plot this data as opposed to, say, that histogram that we drew before? Because when we plot them side by side, we get a lot of information about the differences between 2 groups. Like, for instance, in this case, we can see that the variability of the right sample is much greater than the variability of the left sample. We can also see that the middle value, or the median for the right sample, is much different than the median for the left sample. So looking at them as side-by-side box plots really gives us a lot of insight into the how this data is distributed and compared. Okay, later on in the next segments that you're going to see on Blackboard, there's a video. It's a TED Talk by a Dr. Hans Rosling, and he makes very dramatic use of graphics to communicate statistical information. So that's one of the things that we're going to ask you to watch later on. Okay, it's not going to work so well for us to watch it together right here. Okay, so let's move on. So any questions so far? You're getting a pretty gentle introduction into this stuff. You guys have any questions so far? Okay, not yet. Good. All right, good. Okay, we talked about software. All right, just so you know what's on Blackboard, if you go into the class sessions, where most of you have already gone into, most of the material that we're talking about here, and the link to this class is right here. I'll update the schedule, the class schedule, and the syllabus so that those dates are correct for the project. The next part is the lecture. This is the PowerPoint for Levi's lecture. This is the link for playing it back on YouTube. It's roughly about 45 minutes or an hour. I suggest that, since you're online now, that you watch it now, and it'll supplement the material that we're talking about right now. Okay. The next thing we have is that we have the PDF file that I just went over with you on the software. So we've already covered that. Okay, but then if we move on, we have that video that I mentioned for Hans Rosling. So if you get a chance to play that now, it'll give you a really insight into how dramatic and how informative these graphical displays of data can be. Now, next, there's also a video on the origin of spreadsheets on microcomputers, give you an idea of the impact that programs like spreadsheets had on microcomputers and how important they are to a lot of different fields that involve mathematics. Now, the next thing on there is a link to something called cityprogram.org. Cityprogram.org runs a training session on ethics in human research. All of you guys are required to take that as part of this course and complete a certificate in this. There are approximately about, I guess, 6 to 12 modules, depending on what version of it that you select. And the modules are reading sessions. You read a bunch of information about the history of ethics in human research. You read about policy, how most policies are set in most universities in terms of human research. And at the end of each one of these segments, you get a 5 or 6 question quiz. Okay, you don't have to get great scores on each one of them. I believe that overall you have to get 80%, 80th percentile. I'll get to if you took it before in a second. Okay, so there is a lot of reading to do. So depending on how carefully you go through it, it could take you anywhere from about 3 to 6 hours to complete the readings that you need to do and complete the tests. You can always go back and retake the tests, so don't worry about having an issue with one of the segments or something like that. The reason why I bring it up now is because this class is so compact. We only have 7.5 weeks really to get all this work done. It's better if you do this earlier in the semester as soon as you can, so you get it out of your way, so you don't have that hanging over your head as we get towards the end of the semester, where most students think that that this course is a lot heavier in terms of the material and in terms of the workload. So it's better you get this kind of stuff out of the way early. So we need everybody to complete that before the end of the course. But I'm encouraging you to do it in the next couple of weeks, so that you don't have it. Yeah, you don't have to worry about it at the end of the semester. Now, if you have a certificate previously, if it's less than a year old, you can upload it. And by the way, I'll be setting it somewhere up on Blackboard where you can upload these certificates. Or if you have an issue with that, you can always email it to me. But you'll be able to upload it probably in the assignments section of Blackboard. If you've taken it before and you have a certificate from the past year, you can upload that. You don't have to retake the course. If it's more than a year old, you have an option of taking a refresher course. So you don't have to go through all of the material. It might only take an hour or two to complete. So you have the option then of uploading a refresher certificate instead of the original course. When you go online to do this course, you should make sure that you identify, it's going to ask you to identify the institution that you're part of. Most likely that will be listed under City University of New York rather than Hunter. So the institution is going to be City University of New York. The type of, it'll offer a number of courses for City University of New York. You want to make sure that the one you select references a graduate student. Now, there's going to be graduate student in social work or in medical work. Doesn't matter which one you choose in that regard. Choose either one of those graduate student versions. And you should make sure that it says ethics in human research. The word human should be in there so we know that you're getting the right material. Now, unfortunately, thanks for the link there. Unfortunately, I can't, I have some instructions on how to access this and how to go through those different steps, but they change it frequently. And trust me, I've used up all my emails, so I can't register for it again and go in as a new student. So what I might ask one of you to do is, if it's your first time doing it, as you work through it, if you do a screen capture or two, or you make a note as to what selections you used and email it to me. I'll share it with the rest of the students, or you can share it with the rest of the students on our discussion board. Okay, I'll set up a thread for the city program so you guys can discuss any issues or problems that you had with it. Okay, so that is required. Don't have to do it right away, but I really strongly suggest that you do it as soon as possible. Okay, and then finally, we're going to go through some exercises. Now, these various files are on Blackboard right now, and you can download. You can right-click and download them to your desktop, and we're going to open them up and work with them. We're not going to work with every one of them, but I'm going to start with a few of them right now. So we'll kind of like get a little bit of hands-on at this stage and see what we're doing now. This kind of would be what would normally be the lab portion of this course. Because we are this first session is online, I decided that I would push this to the front rather than do it after the lecture, so that at least we can get an introduction and talk to each other for a little bit. And thanks for the link, by the way. I'm going to start working through these problems. You can do these with me. Some of this, because I'm starting right at the basics with spreadsheeting. Some of this may be really kind of elementary for a lot of you guys, but bear with me. Things will get complicated enough faster than you would appreciate anyway. So don't worry about it. We'll get into some more challenging material. But I want to make sure we all start with the same understanding of spreadsheets. Okay. Now, as I said, you can have three forms. This is Excel. It opens up. It's got a grid with letters across the top that representing columns, numbers across the left representing the rows. So each one of these cells, as they're called, has an address. For instance, this cell that I'm in right now is B2. This cell is B5, and so on and so forth. We can put different kinds of data into these cells, primarily three kinds of data. One kind of data is a label. For instance, a label might be something like month, right? A number might be something like 120, and we can put a function. Now, a function can represent a mathematical operation. It can represent an operation that's done on other cells. For instance, just for right now, I'm gonna take a look over here on the left-hand side here, and again, you can download this. If we're making up an invoice or something like that, you'd commonly see the unit cost for an item, and you see the count, the number that's involved. So I could say, well, that's going to be equal to 10 of these at, and I'm going to use the asterisk to represent multiplication, at $11.20 each. And that comes out to $112. Works great. Another way that I could use a calculation here, notice the first thing I did was I put in an equal sign. The minute I put in an equal sign, SPSS understands that I want to do a calculation. You'll notice also that up here, there's a change in this function line. F of x represents function. So now it's waiting for me to give it some instructions. So instead of putting the number 10, I can tell it I want to calculate the number that's in this cell, in the cell F3. Notice I clicked in there. I could have either just typed in F3, right? Or I could just click into that box, okay, times 11.2 or $11.20. Again, I could type in 11.2. I could type in G, that's G3, I would guess, right? I type in G3, okay, or I could just click into that cell, and it'll understand that I mean that I wanted to do that operation on that cell. Okay, so now we're multiplying the quantity that's in F3 by the quantity that's in G3. I'm going to hit enter, and it does that calculation for me. Okay, so is there anybody now that this is new to? You can post anonymously, or you can send to me personally, but don't be embarrassed. I mean, in the perfect world, I wouldn't ever use Excel either, if I didn't have to. But I know that a lot of people that may not have much experience with Excel spreadsheets. So I want to make sure we got everybody on the same page. So you don't have to worry about it. If you haven't done this before, don't worry about it. We're going to go through a little bit more of this. Okay, so now I could repeat this process here. I could say equals this 20 times 20, or equals F4 times F4. But another way I could deal with this is I could take this cell. Before I do that, let me just take that number 120. I'm going to click into that 120, and I'm going to drag down without lifting my finger and highlight cells below it. So now I can go up to, and there's a couple of ways you can do this. Okay, one way is on the Mac, I can go over to this little item here called Fill, click down on it and say Fill Down. Okay, and it repeats the number that's in that cell in the other cells that I highlighted. Another way that I could do this is I could go up to Edit, Fill, Down, and it does exactly the same thing. Okay, a third way that I can do this, I gotta undo it. Gotta undo it twice since I did it twice, I guess. Third way I can do is I can click on it, and there's a way for me to just grab that corner and drag it down, and it will copy that value down for me. So you got a whole bunch of them. Now on the PC, it's going to be on the right-hand side. That fill down or the fill left or fill right, it's going to be on the right-hand side of the of what Microsoft calls a ribbon, and you'll be able to get to it. But you'll always be able to get to it through edit and fill down as well if you want to. So right now I'm using a Mac. Maybe later on in the semester I'll switch over, use a PC as well for some of the operations that we do. Okay, so you notice I can copy that number down. That works for cells with formulas as well. Now I'm going to copy this down. I'll use this technique. I'm going to copy it down here. So when I let go of this, it's going to copy what's in that cell down into all those other cells. Well, we got a surprise there, right? Instead of 112, we got 400, which is 20 times 20, 10 times 14, so on and so forth. It actually rewrote the formula. It actually rephrased that formula. If you look up here, and that list, unfortunately, there's no way for me to really expand this easily while I'm broadcasting. In that cell is F4 times C4. In the next cell is F5 times G5. So Excel recognized the fact that there's two columns of numbers to the left of this that involve these formulas. So it understood to copy that formula down, but copy it down in a relative manner so that each value is, it contains what a calculation that's been adjusted for location. Okay, so the total, well now Excel has a number of functions built into it. One of those functions is called sum. Okay, so I can tell Excel, notice I type in equals sum, and I put a parentheses in, and now I can tell it I want it to find the sum of a range of cells. Well, we know that 112 is in H3, and I'm going to put a colon in here, and I tell it I want the sums from H3 through H4, 5, 6, 7. Okay, and it'll calculate, close parentheses, it'll calculate the sum of that total. One of the strengths of Excel is if one of these numbers changes, if one of these numbers changes, like this should have been a 20, notice it updates all the other cells, including the total, the subtotal and the total. So that's one of the strengths of this kind of calculating device. Okay, so that's very interesting, but what good does that do us in statistics? So I'm going to move on to the next little example here. Okay, so let's see. This is just another example of this. I just did this to give you an idea of the predicting give you the idea of one of the strengths of Excel, which is this kind of being able to manipulate data and so that you can figure out ways of adjusting your calculations or correcting your calculations without having to redo them all the time. So for instance, let's say we have a budget and we want to know, let's see, our sum equals sum. Now, by the way, if you don't know those functions, you can go up here to this little f of x. If you click down on it, it'll give you a list of all the functions that are built into Excel. And there's hundreds of them, literally. You can search for it by typing this in, and you can actually sort them by type as well. Trigonometric functions, mathematical functions, so on and so forth. We'll save that. Okay, so for this one, I know it's sum, so I can type in sum. As soon as I hit the first parentheses, it gives me a hint that it wants us to list all the numbers. Okay, so this is our budget. This is the amount of money that we spend each month. This is the amount of money that we bring in each month. Credits, okay, and the difference is equal to, let's do that right here, is equal to our amount of money we make minus the amount of money we spend, and that's equal to minus 340. That's a problem, obviously, right? So let's go back over here. We can say to ourselves, let's make an adjustment here. Let's save a little money on entertainment, and let's find a roommate. Okay, notice that as I do this, I can observe what effect it has on the final calculation, and I can know where I'm going with it. So that's one of the big strengths of Excel. Okay, so let's go to graphing demo. You can also use Excel to produce graphics. So for instance, this might represent mold spore counts in a facility. Some of the samples were outdoors, and that's the total mold spore counts and so on. Blow that up a little bit. So I'm going to go over to charts. I'm going to tell it I want to take this data I highlighted, and I want to make a column chart. Okay, and there it goes. Made it for us instantly, right? So it's a lot easier to understand than these numbers are, or compare than these numbers are. So we can see the indoor levels are lower than the outdoor levels of these molds, and so on and so forth. Okay, so if the data is set up properly, you can use Excel to produce graphics pretty easily and pretty quickly. Now, notice these bars are separated, right? This is individual data for each one of these. Now, later on, we're going to be looking at numerical data differently. So this is just an example of how you might create a graph. Most of the time, we're going to be creating different kinds of graphics called histograms, as we spoke about before. So just as an idea of what we might be able to do with Excel. In fact, most of the time, we'll be using SPSS to produce graphics that's specific to statistics. Now, there are functions built into SPSS that are specifically intended for statistics. Okay, so I'm gonna calculate for this sample. I'm going to calculate these important statistics that we were interested before. Okay, and one of the ways I'm going to calculate it is first. Let me copy this. I'm going to work over here for starters. Okay, so now first thing I'm going to do is I'm going to find the mean of this value, right? So what's the mean equal to? The mean is equal to sum of all these values divided by the number of values. So I think there's 10 values in there, right? Well, SPSS actually has a function built into it that you can use to do that. Okay, I can find the average. I don't actually have to do that more rigorous calculation. So the average here is 82.5. SPSS has a function built in for calculating the median. Okay, what's the median equal to? Well, as it happens, median. And sure enough, there is a function, parentheses, it wants me to identify the numbers. And the median is equal to 80. That's the middle number, as it happens. Okay, how about, so there must be an odd number in there. Okay, so how about the mode, the most frequently occurring value? Let's see if we have a function for that. Okay, the mode is the same as the mean. That's convenient, right? Okay, median means a little bit different. Usually in a perfect normal distribution, these numbers are all the same, but we never really wind up with that perfect normal distribution anyway, so we shouldn't be too bothered about that. So now let's talk about the spread. One of the things we're interested in is the range. Okay, now this function, there's a function for the minimum value. Min, it's called. Okay, and as we go on, you guys will get as familiar with these as I am. So the minimum value is 70. So what about the maximum value? Sure enough, there's a function for maximum value. And we know the range is the difference between those two. I'm going to leave that as it is for now. We noticed that there was another kind of calculation for variability called the variance, and the standard deviation. I'm going to abbreviate it SD for now. Okay, I'm going to go through a quick calculation of those numbers manually, just so that for one time that we do this and we all understand where these terms actually came from. So I'm going to take this mean, right? I'm going to put it next to each one of these values. Let me stick an extra row in here. Okay, I'm going to put an extra row in there. Okay. So I'm going to put the mean in here. I'm going to call the mean x bar. Usually we show the mean as being a number that's as x with a bar over the top of it for a statistic, for a sample. In a population, we use Greek letters. We use the letter mu because that's a parameter. We use mu to represent the mean of a population, x with a bar over the top. A little harder for me to draw, so I'll just write x bar. Okay, so I'm gonna take this mean and I'm gonna copy it up here. Equals the mean. Okay, now I'm gonna copy that down. Some of you guys that know statistics, know Excel very well know what's gonna happen here. It's not gonna work, right? Because it's gonna think, oh, it wants me to copy the cells below it down just as it did there since I copied that cell up there. Well, there's a way around that. Okay, I'm gonna undo this. Okay, if I click in here, that's not actually the number 82.5. That's actually the value that's in the cell G13, right? So when I copied it down, it filled in G14, G15, G16 that way. Well, that's called relative addressing. I can instruct Excel to not do that, to actually copy, when I copy it down, to copy the value in that cell, not copy it relatively, but copy the actual value. So what did I do there? I put $1 in front of the G and $1 in front of the 13. That's now called absolute addressing. So when I copy it down, it will copy down that G13 all the way down. So I suspect that many of you that have been lying back and saying, gee, you know, this is so basic. Why am I looking at this stuff? That you might have actually learned something there. Am I right? Have you guys learned something there? Is that something new? Okay, good. It's handy, isn't it? So at any rate, how many times have you been in that situation you wanted to avoid that happening? Okay, so now what I'm going to do is I'm going to say to myself, well, understand how variable this is. I'm going to subtract each value from the mean. In other words, x minus x bar. Okay, what's the difference between each one of these values and the mean? So it's going to be equal to the value, that each individual value minus the mean. Okay, and that one's 2.5, and so on and so forth. Okay, and I'm going to copy this down so get an idea of how much these are spread out. I'm going to add up all the differences from the mean. So if they're very spread out, the difference will be big. If they're not very spread out, the difference will be small. Okay, so equals the sum, okay, of all these values. Anybody want to predict what's going to happen here? What am I going to get? Got a 0, right? Because they're negative and positive. It's the mean. That's what the mean basically is, right? So that's not going to work for us. So I need to find a way to make these all positive numbers. So what we're going to do is we're going to take x minus x bar, and we're going to square it. When you multiply a number by itself, a negative times a negative, it's going to be a positive. So these are all going to be positive numbers. So it's going to be 2.5 times itself, and I'm going to copy that all the way down. Each one of these values squared. Okay, so now I have all of these values. So the bigger the sum of these things are, the bigger the spread is between, and the bigger the differences between each individual number and the mean. So that gives me an idea of how spread out they are. Okay, the only problem is that now I have doubled. I'm going to add this all up now. Sum. So this is the total sum of squares. This is called. This is called the sum of squares, or total sum of squares. Okay, so I'm going to take that sum of squares. It's actually sum of squares are the differences between the mean and the individual values. I'm going to take that sum of squares. I'm going to take that sum of squares, and I'm going to divide it by the number of values, okay, which was 2, 4, 6, 8, 10 values. I'm going to divide it by 10. Well, actually, I'm going to divide it by the number of values minus 1. There's a reason for that. It's called degrees of freedom. There's a reason for that, but for the moment, just take my word for it. We're going to divide it by n, the number of values, minus 1, by 9 instead of by 10. Okay, and I get a number 56. Okay, so that number is called a variance. The more variable the numbers are from the mean, the bigger is that going to be that number, okay, which is called the variance. Okay, now the next problem I have is that number compared to the differences from the mean, that number is a very large number. It's a large number because we squared all these values, squared all the differences. So now I'm going to take that number and I'm going to find the square root of it. Guess what? We have a function called square root, SQRT, and then the parentheses to find the square root in Excel. And I'm going to take the square root of that number, okay, to get that back into the range of the real differences, okay, and that number is 7.5. That number we define as a standard deviation. Okay, now these don't mean a lot to you right now, or perhaps they do mean a lot to you right now because we all have different levels of experience with this. May not mean a whole lot to you right now, but that standard deviation, that variance, the idea of sum of squares, can be very important to us going forward. These are the way that we describe central tendency or the middle of a distribution or sample. These are the ways that we represent the variability or the spread of that information. Okay, so these are important concepts. Just so you know about it, we could have done it this way, right? We already did mean, median, mode. We could have calculated the variance, VAR, I believe, VAR, this way. And we could have calculated a standard deviation this way. Whoops, I did something wrong there. There we go. Got the same numbers as we did before when we calculated it manually, because SPSS has a plethora of these functions built into it that make it very useful for many, many different applications. Now, I only got one more thing I want to show you before I let you move on. I'm already running a little bit long. I really try to start on time and to end on time so that you guys can, anticipate. You don't have to keep waiting on me online, and you also can anticipate moving on and doing some of your other work and so on. So I just want to show you one more thing, and that is this idea of this software called SPSS. And I should be able to open it up here. Okay, so this is what SPSS looks like. Looks very much like a spreadsheet. Okay, except that these cells that we're talking about here are not things that we use to calculate, put functions into, put equal signs into. They're there to organize data. Okay, let me see if I can't find a quick file. Okay, SAV is the file type that SPSS saves data in. Here's one. Oh, can't be opened. Great. How about let's see, what's that common one there? NC birth. Okay. See if I can't get that one open. SPSS not cooperating with me. SPSS can on occasion, especially when you work on a new version, can be a little buggy. Let me show it in the Finder. I'm going to move it up to open it this way. Let me try this. Okay, SAP, where did I put it? Let's see if it opens. Eureka! Just didn't want to open the right way. Okay, so what do we have here? Notice what SPSS does. It shows me this column represents a particular variable. This column represents gender. This column, this is a birth data, 800 randomly selected births in North Carolina. I forget what year this data is from. Marital status of the mother, weeks of gestation of the infant, the amount of weight that the infant gained in ounces and in grams. Total ounces, weight that the mother gained, total ounces of the baby at birth, and so on and so forth. So in this view, it shows me each individual subject, each mother, mother one, mother two, 4, 8, 9, so on and so forth. There's another view which shows me the nature of the variables. That for each column there was in the data view, there's a row in the variable view. So sex is a not. If I look over here, sex is defined as nominal data. So SPSS has to be told the type of data, has to be told the variable name, and so on and so forth. And SPSS is a valuable tool, number one, for organizing this data, but then also for performing functions on it. For instance, analyze. I'm going to go down to descriptive statistics, explore, and I'm going to ask it to tell me the average age of the mother. In fact, I'll ask it for a whole bunch of statistics. And I'll click OK. And quick as a wink, maybe not quite so quick as a wink. I'll hold my breath for a second. So far, nothing has really crashed and gone terribly wrong. Usually it does. So here we go. Right off the bat, it tells me the average age of the mother is 26, 27 almost. I won't read confidence interval, something we'll get into later. The median, the variance, the standard deviation, and so on and so forth. For all 800 of these mothers that we had sampled. So very quickly, very efficiently, it can organize the data. It can present it for us. It can display it graphically. Remember that Boxplot, which shows us the minimum age, minimum mother's age, maximum mother's age, the median age, and the 25th percentile, the 75th percentile, the median, this is 50th percentile, and this is the interquartile range. Okay, so there you have that information. I could also ask it to do some more graphics for me. Analyze. Oops, actually, I get a different selection here when I'm in that view. Analyze, descriptive statistics, explore. This time I'm going to go into plots. I'm going to ask it, create a histogram for me too. I'll say okay. Okay, and SPSS, the way it works is that the data is in one window, the output is in a different window. So it opens up a separate window and actually accumulates this data so you can go through it and examine it. So here, let's take a look at that. We have an interesting distribution. This is our histogram that represents all 800 births, the average age, the age of the mothers for all 800 births. So we can accomplish a lot of statistics very quickly using SPSS. We can also go wrong very quickly using SPSS if we use it inefficiently. Okay, so I'm going to call it a night, and hopefully this is recorded properly. I hope we got a gentle introduction to SPSS, and hopefully my voice will be in better shape the next time we do this. I'll be a little easier to listen to. So, are you guys okay with that? Do you feel comfortable moving forward? Okay, good. Go back to Blackboard and take a look at some of the other videos, including Levi's lecture on data types. And I'll see you guys on Monday. I'll add by within the next 24 hours. I'll add some simple assignment just to get us started. Our official first homework is not quite due yet, but I'll put something up that you can do. But you should certainly start by getting yourself prepared. Download the textbook. Get access to Excel if you can. Purchase SPSS or Figure a way that you're going to have access to it during the course of the semester. So you get set up and so on and so forth. And then on Monday, we'll get back into this. I'll be able to see you guys face to face. You'll be able to ask me some more questions. I'll be able to get some feedback on what kind of problems that you've run into, if you have. Okay? And you can also remind me about any inconsistencies in the assignments or on Blackboard or on the I think that's a good question. I haven't used Google Sheets. I think it's worth a try. I mean, worst comes to worst, you can always fall back on Excel. So I would love if you guys would experiment a little bit and give that a try. Also, those of you that go on to City Program and log on for the first time, just take quick notes on what the sequence is to get to the proper institution and the proper version, so that we can post that for other people as well. Yes, read that section of the text as well for next week. And if you want, you can actually jump ahead to the following section as well. Okay, guys, so good night. I look forward to actually seeing your faces next week. And trust me, this is actually gonna wind up being fun. Okay? So take care. Bye.